Great. Looks like we have quite a few participants here today. It's so good to see so many of you here virtually. I'm wishing you a good early morning, especially for those of you on the west coast of the US today. A good afternoon, a good late evening for those of you joining us from Asia and Pacific, and a very warm welcome to all our distinguished participants today. I'm Tyler Radford. I'm the Executive Director of Humanitarian OpenStreetMap Team, or HOT, and I welcome each of you to our session, Isn't the World Already Mapped? I'll give you a sneak preview of today's answer. The unfortunate answer in truth is no. It may be difficult to believe that as we near the close of 2020, our planet is still not yet mapped in detail. Entire villages and cities home to thousands of people are completely missing from the world's only free and open map of the world, OpenStreetMap. Through an analysis combining the World Risk Index, Global Multidimensional Poverty Index, and extreme poverty data, HOT believes that more than 1 billion people live in high-risk areas that are not fully described in any public data source. Leaving no one behind will simply not be possible without complete, up-to-date, free, and open geospatial data on the world's highest risk areas. Yet millions of people are not being counted simply because the world has failed to ascribe sufficient economic incentives to map the places they live. In 2018, a group of like-minded NGOs, companies, government agencies, and educational institutions set out to fix this challenge. We formed a flexible and open partnership to make rapid advances in filling in the world's missing maps. This is happening through satellite-based machine learning, but perhaps more importantly, engaging citizens living in unmapped places themselves across 94 countries in describing the place they live on the world's digital. So, the world is not already mapped, but despair not. Today, we're going to not only tell you about the problem, we'll pose a solution to mapping the homes and villages of 1 billion unmapped people. And if you're here today, we need you. Every single one of you has an important role to play. Today, you'll hear from 5 panelists. Our panelists from Facebook and Microsoft will explain how the techie stuff works, and my colleagues at HOT will describe partnerships at the country level, supported by the Global Partnership for Sustainable Development Data. These data collaboratives, as we call them, involve citizen volunteers in adding local insight to the world's map in collaboration with national statistical offices. We also want to hear from you today. We need your ideas on how to extend this mapping movement to your country. I'm also proud to mention the vision that we'll talk about today was selected as a world-changing idea under TED's Audacious Project for 2020. Let's kick off today by hearing from my colleague, Rebecca Firth, who gave a TED Talk in the past several months on this topic. So, Ben, can you cue up that TED Talk for us? Thank you. Okay, thank you so much for that inspiring talk. And that's a great way to kind of set the stage for today's discussion and today's following 4 panelists, who we've invited here for sort of a special reason. It's because each of our panelists today has a unique role to play in filling in these these data gaps that are caused by a number of the challenges that Rebecca mentioned. So I'm going to do quick introductions for each of our panelists today. And because we're all lovers of data, especially geospatial data, I'm going to ask each of our panelists to introduce themselves by telling us in 60 seconds or less about their favorite map. So I'm going to start with Dr. Subbu Subramanian, who leads the Maps infrastructure team at Facebook. So Subbu, over to you. Subbu, looks like you're still muted.
All right, hey, good morning, everyone. And thank you, Tyler, and the rest of the team for inviting us to the panel. And I'm really delighted to meet so many of you participating from across the globe. My name is Subbu Subramanian. I work at Facebook. I work on a team called Spatial Computing. That's all about mapping. And we also have a sister team that we work with called Data for Good. And as part of our efforts, we use maps in the context of like bringing more people onto the map, so to speak, partnering with the rest of the companies here featured in the panel. So very delighted to be here. The specific question around my favorite map. My favorite map is this map I ran into just recently that is produced by Scientific American that it looks, usually we look at the flat map of the world, and if you look at Africa versus a country like Greenland, it shows Greenland as nearly as big as Africa. But in reality, it's not even close. And Scientific American did this really correctly proportioned image to show how Africa pretty much swallows up close to 15 nations across the world. Countries like, bigger, Africa is much bigger than China, India, contiguous US, and most of Europe. And for safety measures, put Japan in as well. So it's such a beautiful representation that talks about how large continent Africa is. It has about 20% of the world's population, but most of it is unmapped. That is the other striking one. And yeah, that's my most favorite map of the world that I recently ran into by Scientific American. Check it out.
Subbu, thank you very much. Next, we're going to go to Harsh Govind. So Harsh is a product manager for the Microsoft Open Data team in the Experiences and Devices division. Harsh, tell us about your favorite map.
Oh my God, Tyler, that's a really tough question. And what I'm going to say is currently my most favorite map is the map of Australia. And the reason is that we have been working in Australia. It was our first foray into open data at the Microsoft Open Data team. And we picked that because Australia is a big market for us. And going into that market with the dream of basically having open data serve all of the needs of the user was a big challenge in front of us. And then realizing how this open community came together to help a very small team like ours, which is less than 50 people, to build that stack. There's so many anecdotes that I can share in the past year that we have got personal reach out from community members to understand how we can do this map better, reach out to build the layers, stacked layer by layer, build the entire information stack on open data. And that journey is right now flighting in production on Bing today. So if you go search on Bing, you will come across open data that serves its needs. So it was a big thing for me to just realize how good this open data community is, how far places which are not even mapped correctly, you can reach out to people and get their help. So it's just amazing to see that people coming together to build the best map. So that's my favorite map recently, but it's a very tough question. Too many good maps.
Too many to choose from, indeed. So
yes.
Harsh, you'll hear a bit more from Harsh in just a few minutes on some of the details around how this is all working. Next, I'd like to introduce Dr. Patricia Solis, who is co-founder and director of Youth Mappers and also serves as executive director of the Knowledge Exchange for Resilience at Arizona State University. Patricia, tell us about your favorite map, or choose one of them.
I told you, Tyler, that I agree with Harsh. It's really hard to decide which is your favorite map. It's like asking me which of my children are my favorite. It's difficult. But I can tell you about a map that inspired me recently. And that is the University of Virginia. The Cooper Center for Public Service has a map of the United States. It's called the Racial Dot Map. And the only thing on the map, it's simple and powerful, 1 dot per person in the United States, color-coded by demographics. And it's really powerful to see. You can see the population distribution. You can see how segregated some of our cities are in the United States. And it's something that is, puts the people first on the map. And I think it's a really powerful way of depicting things that we really care about. So I'm really honored to be on the panel today. Thank you so much for inviting me. And I'm privileged to represent the 5,000 or so youth mappers.
Patricia, thank you so much. Next, I'm going to go to my colleague, Shamila Nasozi, who's joining us today from Kampala and serves as GIS Training Associate with HOT. Shamila, tell us about your favorite map.
Thank you, Tyler. So Sibu and I apparently have the same favorite map. So I'll go to my second favorite set of maps. These are the maps that Watch Uganda produces, usually after every field program. So before we go to the field, we always see what kind of data we have on the map at the moment. And then at the end of the project, we look at how much more information we have added, work together with the community members, and always seeing the different smiles on their faces and having everyone involved and looking at this information we created together is always amazing for me. And they truly come as my second best. Thank you.
Shamila, thank you. And last but not least, we'll go to Rebecca Firth, who serves as Director of Community and Partnerships at Humanitarian OpenStreetMap team. Rebecca, thank you again for your talk. I'm re-inspired by your work every time I see it. Tell us about your favorite map.
Hi, thanks a lot for the question, and thanks a lot everyone for taking a few moments to listen to the talk just now. One of my favorite maps is actually the same location that was featured in that talk, which is where I've been living in Peru for the past few years. And there's this amazing map of all of the Inca archaeological sites across the region. And I really like it because Cusco is the oldest living city in the Americas with continual habitation for 3,000 years. And so I think the map also speaks a lot to the kind of citizen-generated data aspects of work that loads of people who are attending this session are also really involved in, showing kind of a focus on archaeological sites, on indigenous place names, on locating places according to what different crops can be grown there, for example. And yeah, it's a really nice example of kind of citizen-generated data on a map.
Great, Rebecca, thank you so much. We also want to hear from all of our participants today. So we'll do a quick round of introductions, and we'll do that through a poll. So let me just cue that up, and we can take a look at hearing a bit from each of you. Okay, great. So what I'd like you to do, you can do this on your phone if you're watching from your laptop today. Go to menti.com and enter in the code you see on the screen there, 6864525. And tell us a little bit about where you're coming from today.
So why the Million Neighborhoods map?
And this is great. It's really fascinating to watch the distribution here. So we have quite a broad range of participants across government, NGO, academia as well represented. So great to see all of the students and professors and researchers joining us today. UN system and World Bank. Donor agencies. If you selected other, let me know who we missed. You can type it into the chat window. And it looks like we have a shortage of media covering important data initiatives. So we'll need to work on that for next time. But thanks for sharing. Let's do one more question. I'm gonna move on to this one. So where are you joining us from today? Choose your region. If you're still looking for that code, it's right at the top of the screen, 6864525. Great, so Americas is well represented. Europe, Asia Pacific, Africa, followed by Middle East and North Africa. Okay. Fantastic. We'll do one more quick question for everybody. So what do you hope to learn or to share with the rest of us or to learn about today? Just a quick thought, it can be a phrase or a sentence or less. And I'd like all of my co-presenters today to kind of think about this as you're giving your short lightning talks and see if we can address some of these points. Great, so we have lots of interesting topics today. The most left behind subpopulation, how to find them, application of machine learning assisted geospatial. You'll hear lots about that in just a few moments. Opportunities for universities, we'll definitely be covering that today. How we can use these techniques on Yemen programming. That's a great, we do want everyone that's joining us today to be able to take what we're talking about today and adapt it and actually apply it for any country. So that's a great one. Earth observations for SDGs, you'll be hearing quite a bit about satellite imagery today. Great, so lots of stuff for our panelists today to cover. So let's go and let's hear a little bit from them. And the way we're organized today is we'll do quick presentations about 5 minutes each from each presenter. And after that series of lightning talks, we'll have about 10 minutes and it'll be an open question and answer and discussion. So let's start with my colleague, Subbu first. Subbu, over to you to talk about how Facebook is contributing.
Thank you, Tyler. And I will open up with a quick presentation. So I'm going to share my screen and see how this works. All right. So, can you guys share my screen, see my screen? Yeah, cool, awesome. All right. I was very inspired to see the kind of participation that is across the globe, as well as the kind of questions that people had as part of the poll. And hopefully I will answer some of them as we go through this, and my colleagues here will also be able to answer more of them. And of course, we'll have a Q&A session we can go over in more detail. At Facebook, we have many maps data sets that are really grateful to work on. But with the focus of this panel being mapping the 1 billion unmapped people, today I will focus on two specific efforts at Facebook. First, I will discuss high-resolution population density maps and how these maps have been leveraged in specifically the COVID-19 context. Second, I will touch on Facebook's Map with AI initiative, where we partner a lot with many of the colleagues here in the panel. The screen that you see here is a visualization of the elderly population in Mexico. So these maps are the most accurate in the world, and we release them publicly for about 170 plus countries on the Humanitarian Data Exchange. Let me start by digging into how these maps are built. First, they are built without any user data. Instead, we combine 1.7 petabytes of satellite imagery shown here and the census data. We developed this approach in partnership with Columbia University and Facebook's spatial computing team, which I support. Let us zoom in closer for an example. This is a rural village in Namibia, where my colleague Alex spent 2 years teaching as a Peace Corps volunteer. This village had a population of around 300 people, almost all subsistence farmers. This is the kind of village one might expect to fit within the 1 billion unmapped. The school at the bottom, I guess you can see that at the bottom left, and the small health clinic at the top of the image had running water and electricity and were made out of concrete and permanent materials. The rest of the structures were made of traditional materials. Our machine learning algorithm does the same thing you do when you sit in the window seat of an airplane. Your brain looks outside and you say, hey, there is a house, there is a house. Oh, there's no house there, it's just a forest. But the machine learning techniques can do it very, very, very quickly using fast computers. The algorithm is trying to spot any 30 meter by 30 meter files in which it is confident that it sees a building. As you can see here, tiles fitting that description are shaded in purple. It can spot both permanent structures and the farm homesteads made out of traditional materials. So if 300 people live in this village in Namibia, we know they only live in the tiles where there are buildings, instead of smearing it across the entire census block. We overlay the model census data from Columbia University, like I mentioned. This gives us a population estimate for each of the 30 by 30 meter tile. So now let's zoom out and just repeat the same method for the entire globe. That is 1.7 petabytes of images and census data for all 7.8 billion people on Earth. Now that we know every 30 meter tile where there is a building, so let's distribute census data over those tiles. In addition to releasing total population estimates for each country, we release demographic breakouts, including estimates for women, men, women of reproductive age, children, youth, and elderly populations. These demographics are understandably helpful for health crises, where certain populations are more vulnerable than others, such as elderly population in the context of COVID-19. Now that you know how these maps are built, I want to talk about two examples where we have seen during the coronavirus epidemic that's ongoing. Back in March, the World Bank was in a COVID-19 response meeting, and one of the key questions that arose was, where are the vulnerable people and where can they go to receive medical attention, whether they are in need of testing or hospital bed? In Spain, the World Bank overlaid our population density maps with health facility data from government partners and roads data from Mapbox. They were able to calculate how far away in minutes anyone is from their closest health facility by road. In this map that you see here, each flag represents a health facility. In green are locations within 1 hour driving distance to their closest health facility, and the places in yellow are an hour and a half from the closest health facility, and in red, the drive is 2 hours or more. The opacity of the color is proportional to the population. Empty areas are transparent, while very populous areas are opaque. A second study focused on dense cities where social distancing is difficult. The German Aerospace Center and the World Bank also use population density maps to identify potential hotspots for contagion and vulnerability in dense cities, looking at cities like Mumbai, Kinshasa, and Cairo. The red areas indicate that the population density surpasses the minimum threshold required to maintain social distance. This paper can inform city leaders and communities who are managing the pandemic because it provides an evidence-based approach to target emergency interventions and avoid a rapid spread of the virus in those hotspots. Their methodology can be easily replicated globally. I want to close this talk by talking about Facebook's Map with AI initiative. In addition to there being 1 billion unmapped people, it might surprise you to know that millions of miles of roads have yet to be mapped. For more than 10 years, volunteers with the OpenStreetMap community project, along with institutions like HART, have worked to address that gap by meticulously adding data on the ground and reviewing public satellite images by hand and annotating features like roads, highways, and bridges. It's a slow manual task, but thanks to AI, there is now an easier way to cover more areas in less time. This effort was originally launched in July 2019, and in a short span of time, more than 400,000 kilometers of roads have already been mapped. How does it all work? There is a computer vision model that can detect the roads on the high resolution satellite image. This is a challenging task since the terrains could be very different. In many countries, the way that terrains are laid out and how they translate to roads can be easy to spot. In others, it's hard. Using homemade training data, this model works across multiple terrain types, as shown in the example here in Ethiopia. Note that some of these lines that you see here in the bottom right are not roads, but actually riverbeds. Sometimes the algorithm can get conflated between roads and riverbeds, and that's where the human mappers come into play and help train the model better. And this is another example of Nigeria, where the road distribution is very different than the one that we saw earlier. And the algorithms are tuned to work on these types of different structures. Finally, you can learn more about population density maps and the work that I just talked about. Maps are mapped with AI in our dataforgood.fb.com site. Thanks so much for the opportunity to speak today, and I'll be glad to share more as part of the panel. Thank you. Over to you, Tyler.
Subbu, thank you very much. Fascinating talk, and I hadn't heard the size of that satellite imagery data set previously. It's really sort of insane. But thanks for sharing with us. Some of the links to what Subbu mentioned are in the chat window, Map with AI, and I think Subbu, you mentioned the Data for Good link as well, so definitely be great to share that with attendees today. Next, we're going to go to Harsh Govind at Microsoft. Harsh, earlier you mentioned your favorite map being the map of Australia. Tell us a little bit more about that and the other work that you're doing.
Okay. I hope everyone can see my screen. Yep. Okay. So our story, I'm super happy to represent my team here today. One of the things I would say is you don't have to take notes while I'm presenting for any links or anything. Our work is open, as open we are as part of the open data team. You can follow us on GitHub, on Twitter, on LinkedIn. We post everywhere, but GitHub has every detail. So if you search Microsoft Open Data or Microsoft Buildings, you'll come across our GitHub. I'm still going to run you through a few things and hopefully answer some of these questions you guys are looking for as you come and see this presentation. So one thing I mentioned that Australia is super close, just because I've been focusing in that region in Oceania for a long time. It also gave me an opportunity to be in that region late last year, just before the pandemic hit. But today I'm super duper happy to announce that we have just released 11.3 million buildings, machine generated buildings in Australia on our GitHub. So you can go download that. It's under the ODBL license. And these buildings will also be made available in the Facebook Rapid tool that Subbu just kind of showed a little bit before. And we continue to strive to expand our coverage worldwide. I'll talk a little bit more about how we got these buildings in a little bit, but I just wanted all of you to check this out. The screenshot is of the buildings overlaid on our imagery. And so it looks beautiful, you know, when you have the map. If I'm saying somebody's going over there, and my favorite example still happens to be Taco Bell. I don't know if Australia has any Taco Bells, but if you just point a drop like pin on the map saying, there's your Taco Bell versus a building, maybe with the height and everything, the map's really beautiful. Of course, we are crazy about our quality and precision. So you see the polygon precision is 98.6%. We try to strive for over 95% polygon precision, and the recall 65%. You can read a lot more about these numbers again on the GitHub page. So our building coverage is expanding. Our first foray into buildings was in the US, and it was extensively covered by the New York Times. I'll share the link right after, but we extracted 125 million buildings in US. And then we just realized, as I mentioned, one of the biggest things about working for an open data team is getting reach out from community, from governments. And so we partnered with this StatCan. It's called StatCan Statistics Canada. It's a part of the government. And we partnered with them to extract 12 million buildings from our imagery. So as you know, Bing has satellite imagery, aerial imagery, and I will also talk about how we use street side imagery a little bit later, but we use these imagery to extract buildings in Canada. And very recently, we've worked with HOT in Tanzania and Uganda and extracted 18 million buildings. So it sounds like a lot, but when you look on the right side, we have only done 14% of the world landmass, right? So there's still a long way to go, but it's really inspiring to see what it is. And I would definitely recommend that you read the article around written by New York Times and how it talks about identifying growth, identifying movement of population, and so many things that you can identify from just having a good map, a good buildings data set that's available for analysis. They've done a very nice analysis of why we got excited about this project and did it. So I would let you guys read that. It's really an amazing article. Even I was really happy to see that. A little bit about how we do that extraction. Don't let this don't let the slide scare you at all. It's really simple. Um, there's a lot of things behind the scenes, but what happens is if you look on this side, you have this really high resolution imagery. We get a lot of imagery from multiple partners, and you can figure out all the usual suspects out there that deliver amazing high resolution satellite imagery. We also have partners who we get extremely high resolution, like under 10 centimeter resolution imagery, which is aerial. So we take this imagery, and what we do is called like semantic segmentation, which basically means we go pixel by pixel and say, what is it? Is it a building, or is it a area which is barren? Is it forest? What is it? And then we end up with blobs. So if you see this image, this is how we get a picture out of our semantic segmentation. So the algorithm has gone pixel by pixel and marked which pixel it thinks is a polygon, right? Is a building. So you got this blob out there. We extract the polygon, and then we do a math algorithm on it to make it, it's called polygonization, where we make it like really hard curved versus, how you see these blob edges, we get these sharp edges. Most of the buildings are in some form or the other, some sort of a polygons. It works well. And we do find issues like this one where it's really hard to figure this out. And that's where the editors come in play and fix this. So it's not, everything is not 100% automated. Once we start seeing some kind of patterns, we try to bring it in and make it part of the algorithm so it becomes smarter and smarter as we go. One of the quick demos I'll show you here is how it works in Rapid. So we don't want to just take this data and ingest it. We want to make sure that the algorithm, as Subbu was mentioning, sometimes the roads are can also be confused with water riverbeds, right? If they're dried up, it looks like road. So what we have here is this tool. Rapid is a Facebook tool for assisted mapping. And here you have the image, the pink polygons that you see are the building footprints. And a user can go in, select, fix it, identify it as a building. If they are native to that region, they can add more attributes and accept and reject. So you're not getting bad data into OSM, right? Okay, so I want to talk a little bit more about what is this open data program, right? So I'm hoping to answer some of these questions. So as I mentioned, our team, our editorial team is really small, less than 30 people. So we actually are very much involved in, we love to train other people with the processes around how to edit an OSM. So if you have any questions around, or you want to get trained on how I can go edit in OSM, all these complex regions, roads, I'm telling you, it's not trivial. It looks very trivial, but once you start doing which is one way, which is dual way, turn restrictions, all those things, it's really interesting that it becomes very tough. So we do go train our partners out there. We also rely a lot on partnerships. So as I talked about partnerships here with Facebook, we also partner with universities. One of the things I would recommend is we recently partnered with University of Washington, Tacoma, and have submitted and got invited to present 2 papers at the ACM 6 Spatial next month. So please come and watch those. We work with universities, we train the students as to what open data is, and then we get their fresh ideas about how we can make the map better. We also rely a lot on government partnerships. So as I mentioned, in Canada, the buildings would not have been possible without StatCan. In Australia, we partnered with Australian Bureau of Statistics, and we grabbed their layers, the places layer, to feed into our map. We also reached out and got reached out by community members in Oceania region. I have a very small, quick story to tell you guys. Basically, we were struggling to identify what are the water bodies in Australia, that because we couldn't figure how to identify if a water body is perennial or is seasonal. It was so interesting. My team and I are having dinner in New Zealand at one of these OSM conferences, and it just happens the person right next to us is one of the government employees, and they said, "Oh yeah, we saw you do that. How about we share this information to you, where we in the government have a layer of information where we mark all water bodies in Australia as perennial or seasonal." And we're like, "Oh, great. Okay, thank you." And then there, voila, you have all of these. Our focus areas have been in Australia/Oceania. We have edited a lot in the past year. It was our first foray into open data, so we kind of constrained ourselves to one of the top regions for us. Now we are venturing out into South America. You saw examples of our work in Africa. We are also planning to step into Southeast Asia and Caribbean islands. So we are expanding our open data efforts. There's a link. I just wanted to showcase, this is a region in Canberra in Australia, and it's just amazing. Open data, OSM has the best map there. You have all the details, even the points of interest have polygons, there's service roads. It's so amazing. And we are sucker for quality, so every time we see this best available data, we want to get it to our consumers. So it's really amazing to see how OSM and open data has forged its way up into being such a data provider for products like ours. That's all. Thank you, Tyler.
Great, Harsh. Thank you so much. Really clear and really enlightening. And I think our last 2 speakers have been sort of incredible at showing you the potential of what could happen when we make available open data sets on roads, on buildings, on population at the national scale. So I think we're only kind of at the tip of the iceberg here. And as Harsh mentioned, Microsoft has now released buildings for roughly 14% of the world, but there's a lot left to do. Our next 2 speakers are going to talk a little bit about what I like to call little data. So taking big data and making it local, super local, adding details and attributes that cannot be seen from satellite imagery. And what happens when little data happens at massive scale? So when we have thousands or tens of thousands or hundreds of thousands or millions of contributors doing this all over the world, using the outputs from Microsoft and as Facebook as a starting point. So our first speaker on this topic is going to be Dr. Patricia Solis. So Patricia, tell us about how university students are playing a role.
Thank you so much. So can you see my full screen? Okay.
Yes.
Great. Thank you.
Patricia, I see your speaker notes view.
Okay. Swapping. How's that?
Yes.
Better? Okay. Thank you. Meanwhile, the sun has come up here in Arizona, so you can see, the light's hitting me a little bit. So I wanted to pick up on a couple of questions that Tyler asked in the abstract for this session. And that is basically, how do we engage people to represent the places that they live in, the local people? And how do we actually use this data to address development goals and speed that up and scale that kind of thing up? And so I'm going to go into that local example. And the answer that we have has to do with young people and students at universities in particular. A lot of people talk about OpenStreetMap as a platform or as a sort of a database, but we think of it as a community of communities. And the community that we're really interested in is the community of young people and students in universities and their mentors. So Youth Mappers has about 5,000 students now. We were started in 2015 on 222 university campuses in 50 countries now. Started at Texas Tech University, West Virginia University, George Washington University, and with the support of the USAID Geo Center. So we are, part of this community and the ecosystem of organizations like Rebecca was talking about. And some of the projects that we do are always purpose-based, whether that's research-based or humanitarian-based. And a lot of this work actually supports the UN Sustainable Development Goals. And I want to give you an example about the goals number 7 and goals number 5, affordable and clean energy and gender equality. And how do we use these tools that you were just hearing about and the data set that you were just hearing about? So this work example is centered on Sierra Leone on the coast of West Africa. There's a vast rural landscape in this country. It's connected by many roads, and much of the population may not have access to adequate or sustainable reliable power. And it's really undetermined exactly how many people and where. And so while the transmission network maps, which connect the cities, might be available, comprehensive distribution network maps, which are at the local level, are really lacking in many places. And especially women and girls can be empowered by access to modern and affordable energy in remote rural communities. They often bear disproportionate labor burden for the households, and so this can help them alleviate some of their tasks. So our goal here is to map those distribution networks. So I'm going to run through the steps with you really quick, and you'll see a lot of these familiar technologies that we were just talking about. The first step is that augmented feature extraction, augmented mapping. And basically, this step uses the AI-supported digitization of roads and buildings from the satellite imagery to locate those populated settlements and the infrastructure, the RAPID tool in particular. And we manage it on the Teach OSN instance of the hot tasking manager. And that links to the map with AI tools of Facebook and Microsoft that you had just heard about. So basically the human view on this to say, yes, this is a road and I know this road, this is my community, what it is where. Some of this can be performed by the entire Youth Mappers network as well, not just with local students, local and global, so it's supported by that network. And we actually have a Youth Mappers validation team that's led by George Washington University that goes through everything that we do and make sure that it's all looking correct and high quality work. So the next step is once we have these fundamental features, right, we need to know exactly where the actual power distribution is. And that's that bigger picture, right, of the local network, right? So just so you can see, this is what the team there has been able to do just since March for across all the communities of interest here in rural Sierra Leone. A tremendous job in a very short amount of time. Shout out to Jennings Anderson for this visualization. So with those roads and building data, we can capture the street view because now we have the roads view. And our youth mappers. We have 5 chapters in Sierra Leone. It's led and coordinated by the OSM Sierra Leone community, thanks to Tommy Charles, and especially mappers from Forope Bay College and the University of Makini. They've been riding along with their motorbikes and their bicycles with the cell phone imagery and capturing the street view, field capture, local mobile collection along those roadways to support what we can see from the road that you can't necessarily see in the satellite imagery, which in many cases, that would be the utility poles. We need to know where those things are locally. So that's where we take that, those street view imagery, and we put this into the step of the remote crowdsourced verification, because we have to also look at those images and make sure that the AI pulling the object detection that's pulling that out from Mapillary is actually performing, and we can validate that with the human eye. So this is what it looks like. This is off the Mapillary platform. You can see each one of these dots is another image. This is what it looks like. And then we can put it into the object detection, the computer vision technology. They have a semantic segmentation algorithm. And then of course, you know, you can pull out where the trees are, where the houses are, where people, pedestrians are, and then of course, utility poles as well. So then that goes into Pick for Review, which is a tool which we can basically validate with remote volunteers, again, anywhere in the world. The youth mappers everywhere are helping to do this so that we can say that, yes, this is a utility pole in this image. So with that kind of information, we can extract all of that data, the buildings, the roads, the utility points, and define the topology of the distribution network. It's really important to kind of see that big picture. We do have some drone imagery to help validate some of that. And once that is put into place, we can model the townships and the distribution grid locally. So those models will inform an off-grid feasibility, a microgrid feasibility study that is conducted by ASU's Laboratory for Energy and Power Solutions. So that can help speed up very quickly. They tell me 90% faster in this design and planning stage to try to understand how that microgrid can be put in place. And the microgrids can be used to augment the power systems or for renewable energy like solar PV and wind. So that gets taken then, of course, into the final step where all of those inputs can be put back into QGIS, to some of the Xendi, the Open DSS, and some of the other tools that the engineers use, so that they can kind of create that innovation about where to improve the power transmission, where people might not be having electricity. We have all sorts of different directions for the research that we want to take this in, and shout out to Nate Johnson and Elena van Hove, who is our team there at ASU. So back to my question, how can we engage people to represent the places they live in? How can we address these development goals? I really think investing in the young people, the students in our communities, investing in the infrastructure that is the universities everywhere, and the Youth Mappers Network as sort of that social and professional network where we connect students up to the private sector, to the humanitarian sector, and they really have a lot to offer. I want to say that, you know, we're trying to find ways to make sure they're not just data producers, but they're also users in their theses and dissertations. We have fellowships for them. We have virtual internships. We have all sorts of interesting opportunities for them, because it's really important that we don't just build the maps, but we build mappers. Okay.
Patricia, thank you so much for your presentation. I love the photos around capturing street view on bicycle with a mobile phone attached to bicycle handlebars. I think a lot of times when we think about street view, we think about the autonomous vehicles driving around, and it's really great to see the alternative ways to capture street view. And that, if you hadn't heard of that tool before, it's called Mapillary. You can check that out. Yeah, really. So as we get to our last presenter today, I think one of the important things is that each of our first three panelists has talked about different stages in building a complete world map, right? We've talked about where are the roads, where are the buildings. Patricia helped talk about once we have that, how can we locate some of the other local infrastructure like the power grid? And then once we have that, what else can we do? Can we start to label the names of those streets? Can we tag a building as residential or as commercial, school or hospital? So our last speaker for today, Shamila, is going to talk a little bit about how that actually happens on the ground and tell us a little bit about her own story and how she became involved in OpenStreetMap. Shamila, over to you.
Thank you, Tyler. Just sharing my screen. Can everyone see my screen? Yeah, okay, great. So I'm glad that I've spoken after all the other panelists because I believe my talk may kind of glue everything together. So my journey through mapping and how I joined HOT. In 2016, I was introduced to OpenStreetMap through a training conducted by HOT and Map Uganda at my university. I was really drawn to the humanitarianism involved and how a single edit on one platform could mean so much to responders in the field. My first campaign was mapping for malaria elimination in Zimbabwe and Botswana. And in 2017, Busitema University was officially chartered into youth mappers. As youth mappers, shown in the picture there, we were able to hold GIS trainings, mapathons, and I believe we built a strong community of mappers that still contribute to OSM to date. I later got an internship with HOT, and well, I never looked back since. I've been working with HOT since 2018, and I'm glad to be part of the team. At HOT, we pride ourselves in our participatory mapping efforts and the power of using local people, local tools, and local knowledge to update OpenStreetMap. The first step in our field programs is remote mapping. This allows mappers to add basic information obtained from aerial imagery like buildings, roads, waterways, and so many other features. This data basically provides a standard base map that mappers that we can use in the field for navigation and planning field engagements. Remote mapping has been improved over time with the development of tools like Rapid that has been mentioned before in the talk. This utilizes AI-generated roads from Facebook and buildings from Microsoft. For example, we were able to use Map with AI to map a district, Butambala, mentioned in the, as you can see in the tiny animation I have down here. This was done, this work would normally have taken us 4 weeks, but we were able to do it within 2 weeks. When extra information is needed that cannot be got remotely, this is when we go on ground. Here, we involve local community members to lead the mapping. Why local, you may ask? This is because the local people know the area better than anyone else and can easily identify the gaps within their community. Through participatory mapping, individuals are empowered to learn to use different tools to map their communities, and this in turn builds a community of mappers that will be invested in updating this data eventually. We have also collaborated with government agencies on different projects, and this is mainly to foster open data and the use of OpenStreetMap and other open source tools within government agencies. We've conducted technical trainings with local government agencies such as the Uganda Bureau of Statistics and the Kampala Capital City Authority. And as a result, more data is being added to OpenStreetMap, and adoption of tools like QGIS, Open Data Kit, and Open Map Kit, to mention but a few. At the beginning of the talk, Rebecca talked about HOT's audacious vision. Through HOT's audacious vision, the Uganda team hopes to grow the OpenStreetMap community in Uganda. We shall do this through supporting university students, youth mappers, and local partners. With a large volunteer base and a bigger community, we shall be able to map, I believe we shall be able to map every corner of Uganda remotely. building onto what has already been done through previous projects by HOD and adding more data, starting with the newly created cities in Uganda. And lastly, we shall not just focus on creating this data, because we also need people to use this information. We shall make sure we harness the power of this geospatial data by training other local partners and humanitarian partners and government agencies to adopt and implement this data in various use cases. Thank you very much.
Shamila, thank you very much. It was really great to hear about your personal journey into mapping. And we want to sort of expand that and help our participants today to start their journeys if they have not already. So I see a lot of questions coming in around how to actually do that. We have about 5 or 10 minutes now to take questions from all of you. We want to hear from you. There's been lots of questions already on how we can expand this work into places where either you're living or working. So we'll talk a little bit about that. There was a couple of questions that came in via the Attendify chat. So if you do have a question, please type it in directly into the Zoom chat window, and I'll read those off to the panelists, and we'll try to get you answers in the next 5 minutes or so. So we had a question coming in, and this one is for Subbu. The question was, can you say how many different types of images need training data, like the rivers versus roads issue or concrete versus earth in buildings?
Yes, as we start making advanced progress in mapping more of the structures, the need for more training data is only immensely increasing. Initially, we started with roads. Obviously, like understanding polygons is important. As Harsh talked about, buildings is the next step, and we collaborate a lot on all of these efforts. And the OpenStreetMap community, along with HOT and Mapillary and others, have enabled a bunch of tools as well as people who are helping put all of that into a really nice human curated training data. And there is even more need for such things to be done across the globe. And the need for each country is different. And people locally who are really deeply understanding of the local structures and constraints and can easily spot the difference between the various structures should actually contribute more, so that we can make the scale and coverage of all of these various features to be as efficient and as fast as possible. Machines can do a lot, but humans are the key, and the more training data we have, the better.
Thank you, Subbu. Patricia, I think we've responded to these already, but lots of questions coming in around Youth Mappers chapters. So is there a chapter in the US? How can I get involved in Nigeria? Anything you want to say or add to that question?
In case you haven't seen my answer in the chat, I'm trying to respond to each of you, but please feel free to go to www.youthmappers.org, and you can see there under chapters, you can see the list and the map of where all the chapters are. There's 222. Yes, we do have some in the US. There are some countries where we do not yet, but we do have regional ambassadors that will help students form their own chapters, and you can always email info@youthmappers.org and we'll walk you through the process.
Patricia, thank you very much. Let's move on to a couple. We'll do a rapid round of responses. So was there ever an attempt to map during an armed conflict? Would anyone like to take that question? Okay, I'm happy to, I'll give my best to attempt at this one. So yeah, regarding mapping during armed conflict, what HOT's been working to do over the past few years is really work to help our community understand and make their own decisions on when to map and when not to map. So today we talked a lot about mapping and how to help communities to add themselves to the map. There are situations that when weighing the pros and cons or the potential risk factors, it may make sense not to add an area to the map because of the risks that it may pose. In order to answer that question, it really requires a local analysis of risk and weighing that risk versus the possible reward of making data open. So I would say we would always err on the side of doing what's best and what's safest for communities and actually recommending not mapping. But at the end of the day, it's up to community members themselves to make that decision about what goes onto the map or not. And that's one of the things with one of the powerful bits about OpenStreetMap is that anyone has the power to add to the map, but everyone also has the power to keep things off of the map if those things are private or feel that damage may be caused by adding them to the map.
Tyler, I would
Okay.
just reinforce your answer on that and say that just like HOT, Youth Mappers also follows an ethical code, and we have our ethics statement on our website as well. It's very important. Thank you for the question.
Okay, there was a few other questions. One came in via Attendify. So some recent blockchain AI startups such as PlanetWatch and Breeze Technologies are using hyperlocal affordable sensors to track air quality in some of the remotest regions. Could the sensors double up as both identity mapping tools to help with the mammoth task? Thank you, Suman, for that question. Would anyone like to take a stab at that? I'm not aware, I don't believe we have, most of our sensors right now are drones or satellites, not the sort of local sensors, but I'm curious to hear if anyone does have experience using in situ sensors. Great. If you do have other last minute questions, please feel free to add those to the chat window and we'll try to answer them as we're closing up. But seeing as we only have a few more minutes left, I'd like to give 60 seconds to each panelist to kind of give the participants today one thing you would like them to take away or one thing concrete that they can do coming out of this session to help to expand this mapping movement. And Subbu, I'll start with you. 60 seconds.
Well, thank you. I mean, this has been fantastic to see the participation from all the audience and the kind of questions that have been raised so far. You know, it's always tough to do these kinds of panels in online events, but there's also an advantage where you can actually see what's going on and how people are reacting to it in real time. So glad that we could do this. In terms of the specific action item or something that I really would love for people to take away, OpenStreetMap is a great repository for lots of applications like you saw, among them humanitarian aid work, civil services, infrastructure development, and whatnot. So my main call to action would be familiarize yourself with the tools and interfaces and contribute as much as you can to OSM. We have OpenStreetMaps. Mapillary is another great platform that's now part of Facebook, has a lot of great tools like we saw in the talks earlier. And I really would like for you to, if you're interested in mapping, to embrace open data, embrace the tools that many of us and of course our partners have continued to build and learn them. They're not hard. Of course, there is elements that always we can improve. Give us feedback. But once you invest in them and once you start using them to expand coverage and quality of the maps around you, I think the return on investment is immense.
Subbu, thank you. I'll share some links in the chat where participants can try out mapping for themselves. Harsh, over to you. One action you'd like the audience to take away from today?
I would like them to take away many, many actions, but one of the biggest things that I would say is you're not alone. And even though you feel that, what would I do mapping a few buildings here or there, or a few street names here or there, is that really making a difference? Yes, it is. You can see we covered the entire continent, and with very few people, with technology, but eventually the biggest power, the biggest force on our side to get this done was the people. They were the people on ground who, when we put a question on the map node, if somebody responds and say, oh yeah, it is, or they point us in the right direction saying, by the way, there is that data, or this is how we have been doing things. It makes our life so easy to get there's so many, as you heard all the panelists talk about, there's so many reasons why mapping data is so, so important. And yes, technology is making leaps and bounds. You know, AI is becoming a very important aspect of it. But remember, people are at the core of all of this. Each and every picture that you upload on Mapillary or OpenStreetCam, each and every update you put in the map is really helpful in getting us there. So thank you. And please take
Harsh,
that
thank
as
you.
the takeaway. Thank you.
Thank you, Harsh. Patricia, one action you'd like participants to take away from today?
Yeah, I sort of building on what Harsh and Subbu have said, you know, put people at the center, and please engage your students and your young people. I think it's just an incredible way to make sure that this community is inclusive. Actually, Youth Mappers is about 40% women, and with this is unheard of in many of the technical sectors. And so it's one way to make the map better. It's better quality. And this is the future. Engage the young people and make them at the center of this, not just as data, you know, as data producers, but they are innovators and leaders.
Teach someone to map, teach your children to map. Shamila, over to you. What's one action you'd like participants to take?
Thank you, Tyler. I think the one action I'd like participants to take home is to go to OpenStreetMap, go to osm.org and search for your village. Now, I know some of us may be in urban areas. We usually try to map these areas, but look for your village. If it's not on the map, edit, add that edit and map it yourself. This is how we build the map. This is how we add everyone and make the map visible and available for everyone. Thank you.
Shamila, thanks. Very concrete action there. Rebecca, over to you. Final thoughts or actions you'd like the participants to take.
Thank you very much. Yes, I just typed a couple of links in the chat here. I think one action people can take is thinking about how to use the free existing open data in the platform. And there's some links to download that, and also to request us to do more mapping in places where maybe you're working and the map isn't complete yet. And also just a really quick plug, HOT's currently hiring for some regional directors in East Africa and Asia. And if you might be interested to apply for those jobs or know anyone who could be, please share those advertisements with them. Thanks very much.
Thank you to you, Rebecca, and thank you to all of you who joined us today. I hope you enjoy a 10-minute break before the next session, and have a great rest of the day. Take care.
Thank you so much. Bye.
Thank you.